This video will demonstrate how to choose equations for solving gas law calculations. There are 5 example problems. Be sure you set up the problems by copying down the data and the equations, but allow 3 to 4 lines to work the problem out for the next video. To review, these are the gas law equations from the first video. These will be used to solve the gas problems. Solving word problems. The variables must be determined first. This will guide you to choose the formula to use. Remember that our variables are pressure, which is measured in atmospheres, kilopascals, or millimeters of mercury. Volume, which is measured in liters. You can find the number of liters from milliliters by dividing by 1,000. Our temperature will be Kelvin. Kelvin is going to be degrees Celsius plus 273. Moles, the variable for that is N. With our first example, when you read the problem, find the data and the unknown. Notice that here we have 40 degrees Celsius is one piece of data that's given. A second one is 2.32 liters. Then 75.0 degrees Celsius. Carry your data down. And then we can determine what the variables are that go with the data. So 40 degrees Celsius is going to be T1, my first temperature. Then my 2.32 liters, that is my first volume. The 75.0 degrees C is my second temperature. Anytime we do calculations, we have to convert it to Kelvin first. To convert to Kelvin, we're going to add 273. Do that before you do anything else at this point. So here we end up with 313 Kelvin for 40 degrees. For 75 degrees Celsius, that's the same thing as 348 Kelvin. Continuing to read, we find out what we're looking for. What will be the volume? So V2 is equal to question mark. Using the data, using the variables that were given, T1, V1, T2, V2, go to your equation menu and find an equation that has those variables in it. That is correct. We would choose Charles's law. So we'll take it over. Here's Charles's law. This is as far as you should set up. Remember to leave yourself, 3 to 4 lines so that we can solve it on the next video. Problem 2. Looking at this problem, let's find the data. We're given 14.0 liters. We're given 1 atmosphere. We're given 1.54 atmospheres. Bring the data down. Now, atmospheres. Atmospheres is a measure of pressure. So that's going to be our P1. 14.0 liters. Liters is a measure of volume. So that's going to be my V1. And then atmospheres again, that is my P2. Going back to the question, let's see what we're looking for. Find the volume. So it looks like we're looking for V2. V2 is equal to question mark. Once again, using our variables, let's take a look. We have P1, V1, P2, and V2. Go to your equation menu. Find one that has P1, V1, P2, V2. Yeah, that is correct. It's Boyle's law. Go ahead and carry that equation over to your problem and copy it down. Once again, this will be problem 2. Go ahead and allow yourself some room at the bottom because for the next video, we'll come in and actually solve the problem. Problem number 3. Find the data and the unknown. Notice that here we have total pressure is 600 millimeters of mercury. We are also given 434 millimeters of mercury. Bring your values down. There's my PT total pressure, and there's the partial pressure of helium. Let's go back and read and see what we're looking for. What is the partial pressure of hydrogen? So that is what we're looking for. Now we have P total is equal to P helium plus P of hydrogen. So this is going to be like P1, P2. So go to our equation menu, find an equation that has PT in it. Perfect. Dalton's law. Go ahead and bring Dalton's law of partial pressure over. Sometimes it's called Dalton's law of partial pressure. In this type of problem, you'll always have partial pressure somewhere in the question. Looking at question number 4. Find the data and the unknown. Okay. Notice in this problem it says determine the volume of a container that holds 2.4 moles of a gas at STP. STP is standard temperature and pressure, which is the same thing as 22.4 liters is equal to 1 mole. So let's look for our data again. Well, there's 2.4 moles, 22.4 liters, and 1 atmosphere. Bring our data down. 2.4 moles, 22.4 liters, and then my 1 mole. There's my N. N is moles. My 22.4 is volume, and N2 is 1 mole. Looking at the variables that I have, N1, V2, N2, oh, I don't know what I'm looking for yet. Let's see. Determine the volume of the container. So I'm looking for V1. Using all my variables, go to my equation menu. Looks like it's Avogadro's law. Choose the equation. Copy the equation down. Make sure you leave yourself some room so that you can solve the problem on the next video, please. Okay. Problem number 5. If the pressure exerted by a gas at 25 degrees Celsius is in a volume of 0.044 liters is 3.81 atmospheres, how many moles of the gas are present? Once again, read the question, find your data, and find your unknown. Looks like we're given 25 degrees Celsius, 0.044 liters, 3.1 atmospheres. Bring our values down. Let's give each one of those a variable. So 25 degrees Celsius, same thing as temperature. So there's my T. 0.044 liters is the same thing as volume. So there's a V. 3.81 atmospheres. Atmospheres is a measure of pressure, so it's P. And going back, what are we looking for? How many moles of a gas? So there's N. N is what we're looking for. Go ahead and add our 273 to our Celsius to make it a Kelvin value. And then notice that my pressure is in atmospheres. So we'll need an R constant. Our R constant in atmospheres is 0.0821 liters times atmosphere mole times K. Considering all our variables, go back to our equation menu. Find the correct equation that has all those variables in it. Good. It's the ideal gas law. PV equals nRT. Copy it over onto your problem. And this is what we will solve for on the next video. Once again, leave some space. In summary, solving word problems, the variables must be determined first. This is going to guide you to decide which formula it is that you're going to use. Once again, there's pressure with the units of atmospheres, kilopascals, or millimeters of mercury. There's volume with the units of liters, and you can convert liters from milliliters by dividing by 1,000. Temperature needs to be in Kelvin before you do the calculation. To obtain a Kelvin, it's going to be degrees Celsius plus 273, and then the number of moles.